In this video, we're going to talk about operations that we can do on strings and languages to make new strings and languages. So, what I'll need you to remember coming into this video is the definitions from the previous video this week. So what a symbol is, what an alphabet is, what a string is, what a language is. What I will also need you to remember are some of the basics of set theory from your previous courses. So what intersection and union and set difference mean for sets. So if any of that is a bit clouded for you, I'd go back and cover that sort of material until you know what I'm talking about in this slide before you watch this video. So the first operation or property that we're going to talk about is the length of a string. So we denote that using the same norm that we use in a lot of other mathematics, and that's the two vertical bars either side of the thing that we want to find the size of, or in this case the length of. So the first thing that's important to know is that the length of the empty string is 0. And the length of a string in general is however many characters that are in that string from the original alphabet. So if we talk about a simple alphabet here consisting of the lowercase and uppercase letters, and this string A, B, C, D, the length of this string is 4 because the string has 4 characters in it. But if we talk about this more complicated alphabet here where we've got these composite symbols, it's important to remember that the length of a string is how many symbols are in that string. So because our indivisible symbols are listen, sent, and closing, a string consisting of listen is in this case length 1, or a string consisting of sent, listen, closing is length 3. Another operation that we can talk about, which is very simple for a string, is the reverse of a string, and we denote that using sort of an uppercase R index, so sort of like W squared, but it's W to the capital R. What that is the string in reverse order. So for a string consisting of the symbols 1, 2, 3, W reverse is just 3, 2, 1. Now it's important to remember that we're putting the symbols in reverse order. We're not flipping the symbols around on their y-axis. So the reverse of greater than or equal to, less than or equal to and less than or equal to is the exact same string, less than or equal to and less than or equal to. It's not this string here. Okay, so we reverse the order of the symbols. We don't flip the symbols around. Now again, I'm going to talk about this language here, consisting of listen, sent, and closing. So the reverse of listen is just listen, because this is really only one symbol in a string. So I can't put it in a different order. It is not the letters that we've used to make up that symbol in reverse order. It's not netzel. The next operation is the concatenation of strings. Now you probably already know what this is from your beginner programming courses, but concatenating two strings just means simply sticking one onto the end of another. So if I've got one string called W1, which is 1, 2, 3, and another string called W2, which is decimal, decimal, 9, 2, then W1, W2 next to each other, which is how we denote concatenation of two strings, is simply 1, 2, 3, decimal, decimal, 9, 2. And the reverse ordered concatenation, W2 followed by W1, is just decimal, 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 9, 2, 1, 2, 3. Or we could repeatedly concatenate any number of strings. So in this case, we can concatenate W1 to itself 4 times, and we just get 4 repetitions of 1, 2, 3 over and over again. Now, an important thing is what happens when we concatenate with that special string, the empty string. So for any string, so for all W, the empty string concatenated with that string is equal to that string concatenated with the empty string, which is just equal to the original string. So that means that anytime I've got empty strings in a concatenation, I can simply chop them out and ignore them. And I end up with empty string, W1, empty string, W1, empty string, just simply being W1, W1. Another operation on strings is replication. So replication is simply concatenation of the one string a set number of times. So we talked about before how we could concatenate a string to itself 4 times, where we did that before. Well, we can concatenate a string to itself any number of times, and we will represent that using the power symbols, so W to the n. So a few basic definitions. A string to the 0 is the empty string. So 0 repetitions of any string is always nothing, so it's the empty string. 1 repetition or 1 replication of a string is simply the string itself. Then we have a string to the power 2, so a replication of a string twice, and it's simply the concatenation of the string with itself. A string replicated 3 times, so W to the 3, is simply the replication of W to the 2 with the concatenation of W to the 2 with W, which is just the concatenation of the string W 3 times. So we can represent this as a recurrence relation. Our basis is that a string replicated 0 times is equal to the empty string. And then our update step is that a string replicated n plus 1 times is simply the string replicated n times concatenated with the string. So what I've just talked about has been operations on strings. We're now going to start talking about operations on languages. So remember, strings were just a single sequence of symbols from an alphabet. A language is a set of those strings. So it's important to remember that languages are sets. Therefore, all of the operations that you already know that apply to sets apply to languages in exactly the way you would expect. So the union operation, we know that when you're talking about 2 sets, the union of those 2 sets is simply all of the symbols that are in either one or the other set. It's exactly the same with languages. The union of 2 languages is just a language consisting of all of the strings that are in either the first language or the second language. The same for intersection. So that is the set of all elements that are that are in both one set and another set. It's the same for languages. The intersection of 2 languages is the set of all strings that occur in both of the languages. Negation is an important one because when we talk about the negation of a set, it is all of the elements that are not in that set from some universe. So we always do these Venn diagrams when we're talking about this, where we've got the set that we care about in here, and then the negation is all of the stuff not in that set according to some universe, which we represent using that rectangle. Now, in the case of languages, the universe is the alphabet clean that we were talking about. So the universe is the set of all strings that we can make using that alphabet. So whatever alphabet we need to use for the language, the negation of that language is all of the strings that can be made using that alphabet that do not occur in the language. Set difference is the obvious one. It's the set of all strings that are in the first language but not in the second language. So we talked about what the reverse of a string is. We can also find the reverse of a language. So it's a single operand function, so it only takes one language. So we've got L, and it just gives us the one. We take the one language and we apply the operation. So the way that single operand functions like this work, when we apply them to languages, is that they produce a new language by being applied to each of the strings in the language. So if we've got a string in a language, so let's say a language contains the string AB, then we take that string, apply the operation to it, and then stick the result in our result language. So in the case of reverse, if AB was in the original string in the original language, then BA would go into the resulting language. So the reverse of a language is simply the set of all of the strings from the original language reversed. So in this case down the bottom left here, we've got AB, BC, CD, and EFGH. L reversed is simply the set of the strings formed by taking the reverse of each of the strings from the original language. So it's BA, CB, DC, and HGFE. If we had a language that was defined a little bit more nebulously, so it's just the language where we've got any string where all of the ones are before all of the zeros, so anything that you can build using that sort of definition, where you've got a set of ones, a sequence of ones followed by a sequence of zeros, the reverse of that string is the reverse of that language is simply each of the strings flipped. So you can see straight away that it's going to be the set of all strings that can be built by having all of the zeros before all of the ones. In this case here, we've got an interesting case where the language consists of strings which are their own palindromes. So it's 1, 1, 1, 1, 1, 1, and for some reason I've put 1, 1, 1 in there as well. So let's assume this is a string of 4 ones. The reverse of each of those strings is themselves. So if I reorder some ones, I'm always going to get the same number of ones. So the reverse of L1 is actually L1 itself. The concatenation of languages is a concept that often confuses new students. So you'll remember before, from earlier in this video, that the concatenation of what the concatenation of two strings was, and that was a fairly simple concept. The concatenation of two languages is just the set of all strings that can be produced by concatenating all of the strings from the first language with all of the strings from the second language. So if we consider this pair of languages L1 and L2 down the bottom here, you can see that the result of concatenating L1 with L2 is all of the strings from L1, which in this case is just an A, concatenated pairwise with all of the strings from L2, which in this case is a B and a C. So we can see that we end up with AB and AC. Now order is important. So we consider all of the strings from the first language concatenated with all of the strings from the second language in that order. So when we concatenate L2, L1, we end up with the reverse strings. We can concatenate a language with itself, in which case it is just the concatenation of all of the pairs that can be made from that language. And we can concatenate repeatedly, in which case what happens is the result of concatenating the first two languages, is concatenated with the next language, which is then concatenated with the next language, and so on. So I've concatenated L1 and L2 with itself down here to show you what I mean when I say every string from the first language is concatenated with every string from the second language. So the strings in L2 are B and C, and the strings in the second language, which is just L2, are also B and C. So what we end up with is all of the strings from the former concatenated with all of the strings from the latter. So we get BB. We also get B with C. And we get C with B. And we get C with C. So you can see that in general, the number of strings in a language concatenated with another language is going to be equal to, or bounded by, the number of strings in the first language multiplied by the number of strings in the second language. Okay? Now, before we talked about the replication of strings, in which we used the power operator, and the same concept makes sense here. If we consider the replication of a language 3 times, then that's simply the concatenation of the language with itself in 3 elements. And if you think about how concatenation of 2 languages works, and so on for 3 languages, then for a little bit, if you pause this video, you should be able to come up with what L2 concatenated with itself 3 times is, and you should get the following. So if you remember from the previous video, I talked about all of the possible strings in a language being all of the possible strings that can be built from an alphabet being the alphabet to the power of an asterisk. And I mentioned the word the phrase clean star there. The clean star is a very important operator for this course, and it is defined with respect to the concatenation that we've just talked about before. So the clean star is a single language operator, so it only takes one language, and the result is the language made up of all of the strings that can be built by concatenating any number of strings from the original language. So let's talk about a really simple case, and that is the language which just consists of one string and A. The clean star of that language is A to the 0 and A to the 1, so A concatenated with itself 1 time, and A concatenated with itself 2 times, all the way up to ad infinitum. So it is all of the finite length strings that I can build using an A. So there's no upper bound. This resulting language is infinite in size, and it consists of the empty string, an A, 2 A's, and continued on, any number of A's. If we talk about this slightly more complicated language here, L2, which consists of 2 strings, an A and a string consisting of BB, then L2 clean star is the language consisting of the empty string and all of the strings that I can build up by jamming those 2 strings together as many times as I want. So it could be all of the A strings containing A's, all of the strings containing an even number of B's, or any mixed combination of sticking A and BB together over and over and over again. Some important definitions. The clean star of the empty language is the language consisting of the empty string. Now it's important because the empty language is not the same as the language containing just the empty string. They are 2 different things. The one on the left has no elements. The one on the right has 1 element, which itself is the empty string. Also, the language consisting of just the empty string, when we apply the clean star to it, we get that same language back, which is just the language containing the empty string. Now I'll also briefly mention the clean plus operator. So the clean star operator was we stuck an asterisk in the power position. The clean plus operator, we just put a plus in there. And all the clean plus operator is the clean star, we apply the clean star to the language, and then we concatenate the language to that result. So the clean plus sounds important because it looks ostensibly different. So the clean star was the language that we can make up by concatenating 0 or more elements from a language, and the clean plus is the language that we can build up by concatenating 1 or more elements from the language. But really the only difference between the clean plus of L and the clean star of L is the possibility of the empty string being inserted. So if the original language had the empty string as one of its members, then there is no difference between the clean plus and the clean star of the language. If the original language did not have the empty string in it, then, I've written this down incorrectly, then the only difference between the clean plus of the language and the clean star of the language is that the clean star will have the empty string in it. So the clean star of the language is simply equal to the clean plus of the language unioned with the language containing just the empty string. So just remember, it looks like the clean plus might be significantly different, but the only difference is with respect to whether or not the empty string is guaranteed to be in the result. So when we talk about the clean star of a language, that will always contain the empty string. The clean plus of a language may or may not contain the empty string, depending whether or not the original language contained the empty string or not. So there was a lot in this video, but what you should understand from now is operations on strings, such as the length, concatenation, reversal, and replication operators. And you should also understand the operations on languages, including the basic set operations, such as union, intersection, negation, and set difference. So I'll just highlight that these two things really mean the same thing. They're both just different symbols for set difference. We can also talk about other operations in the languages that we just defined, which is the concatenation, reversal, replication, and the clean star and plus of languages.